Hi guys, this is Sandra Russell. I'm a sales engineer with Splunk, and I want to talk you through a use of Splunk that we did for a customer. This customer came to us with Cisco Meraki data, and I am not the expert on this product by any means. What I can tell you is that it's a wireless device that our customers had placed in a certain part of their facility, and they asked us to use the data generated by that device to determine line wait times. They have to protect their privacy, I'll be vague and say that they run a facility that where they are interested in tracking and broadcasting line wait times throughout the day, right? So that customers can know which line is better than any other line. And I will also note that the data we're looking at today is completely fake generated data, not actual customer data. But the data that they sent us and that the Cisco Meraki device generates looks like this. We'll just look at the raw event. We just got a text file with line after line that looks like this, with a timestamp, the client MAC address. So the way that this data gets created is that when somebody with a Bluetooth device with Bluetooth enabled walks by the Meraki endpoint, it writes an event to the log, right? So, and it records the time that it happened, the MAC address of the client that walked by, whether or not that that Bluetooth device is associated with the Cisco Meraki device, and in most of the time with our data it was false. And the MAC address of the device, of the Meraki device itself. So this is always going to be the same. But what we ended up with was some rich data. They gave us about a week of data, and we did some calculations to determine wait time. The challenges that we had with the data, with any kind of data that you would get related to this kind of use case, is that it's noisy, right? So they gave us the luxury of not having to precisely calculate line length and therefore wait time. They allowed us to, just estimate based on 5 buckets, right? And in a real world situation that makes sense, because there are a lot of factors that no data, no matter how rich, could really tell you regarding like the precise wait time at a given moment with a given line, right? But you can estimate and categorize them into buckets, and they told us 5 buckets, anywhere from like there's no line, wait time is less than 5 minutes, 5 to 10 minute wait, and so on, right? The other challenge we had is that the data is noisy. Like there are going to be MAC addresses that show up that are not people waiting in line. They might be employees. They might be people lingering next to the line. They might be just devices hanging out because it's just any Bluetooth enabled device. Conversely, though, there may be people in line that don't have a Bluetooth enabled device. So again, the data is noisy and it's not precise, right? Which again makes the bucket factor critical, right? And also, like, there was some noise in the data that was misleading. In other words, like somebody could conceivably wait in line, then experience the whatever they were waiting in line for, and then come back and wait in the line again, and that's conceivably possible to do in even like a 10-minute period, right? So the data just wasn't pure and clean, such that we could do something like measure the duration that somebody was showing up in the Meraki data. Things like that were not, given the noise of the data, were not a viable way to approach it. So instead we approached it in a different way. What I did, and I'm going to walk you through the search step by step. So again, this is the raw data, and the things that really matter here are the client MAC and the timestamp, basically. And this is the final search that we saw on the first screen. This is it with the query. So I'm going to break it out kind of line by line here. The first thing that I did was group the data into 15-minute chunks using time chart command. So that's all that does, is just group events into 15-minute chunks. In this case, you could do 10, 100, 1-minute chunks if you thought that was useful, however you would like to do it. And then count the number of distinct client MAC IPs that you see at that time. So effectively that means that like at between 2:30 and 2:40 p.m. on May 5th, there were 44 distinct client MAC addresses that showed up that were getting, that were talking to the Meraki device, right? So there's that. And you get a line, a graphical representation that makes sense based on the data. We know from other analysis that peak times are May 6th and May 8th, and you see that reflected here. The next thing that we did is calculate the average and the standard deviation for each of these values. Now, we could have gotten fancier. I mean, this is fake data, so we assumed that this was a 24-hour facility. And so that makes the average and the standard deviation calculation make sense, right? If this were not a 24-hour facility and like say between 5 p.m. and 9 p.m. and 9 a.m., the data there shouldn't be used. We might cut it out using a where command, where date hour is greater than 9 and less than 17. We didn't need to do that here because we just are pretending this is a 24-hour facility. But what you want basically is the average value, the average number of distinct MAC addresses you see in a 10-minute period during working hours, right? Because that's just going to give you that middle line, right? The standard deviation is a way of breaking up the rest of the data in intervals. It's a way of coming up with an interval that makes sense for grouping the data into separate buckets. So that is exactly what we did. Like let's start with the average and work backwards. We created a field called 5 to 10 minutes, and that's just the average value. That's this yellow line. Less than 5 minutes is the average value minus 1 standard deviation. Because our average was so low, we just went 1 below, but we did go 3 above actually. The 10 to 15 minute range is the average plus 1 standard deviation. The 15 to 30 minute range is average plus 2 standard deviations. And the 30 plus minute range is average plus 3 standard deviations. And then we did some nice like renaming and things like that just to kind of clean it up. And that's how we ended up. So we ended up with a way to visualize the solution, which was, it looks intuitively about right. Like if you see this few people in line, you have basically no wait, less than 5 minutes, and you can work your way up. This is 5 to 10 minute line. This is the 10 to 15 minute line. This is the 15 to 30 minute line. And this is the 30 plus minute line. Like if you're over 3 standard deviations away from the average, you're really getting into your peak hour usage. And so that's what we did. And in a real life situation, you could run a query like this over the last 10 minutes and determine which of these buckets it falls into. You could, using Splunk's API, broadcast that result of that search into an app or say a dashboard that's visible throughout the facility, anything like that to help your customers know which lines are the shortest and which lines they should avoid for the time being. Thank you very much.